Okay, let's get into specific forecasts. This is the Imd Forecast System, which has been developed since about 2009 and fine-tuned. It started with seasonal forecasts and then went into these extended range and then onset forecasts, and keeps now making forecasts at smaller and smaller spatial scales for various applications like agriculture and health. This is a schematic diagram. It got its own massive supercomputing facility and has increased the resolution and made many region-specific improvements in convection and so on. This is the Indian Institute of Tropical Meteorology coupled forecast system model, seasonal and extended range prediction. Atmospheric model is the global forecast system, and you can see this is T382, which I think amounts to about 38 kilometers, if I'm not mistaken, 64 levels in the vertical. Land model is NOAA. There is a sea ice model. There is a coupler which they have introduced also for the Earth system model. They modified this for the Earth system model. Ocean model, I think, is now MOM V5, if I'm not mistaken. It's fully global. It's run at 0.5 degree and 0.5 degree resolution, a stretched grid in the tropics at 1/4 degree with 40 levels in the vertical. So this is one of the higher resolution models in the world for a seamless prediction system. Atmospheric initial conditions are from GSI, which is provided by the National Center for Medium Range Weather Forecast. This is the ocean initial conditions from GODAS, which is done at INCOIS, the Indian National Center for Ocean Information System. So here is the various things. Obtain ocean atmosphere initial conditions from these centers, generate ensemble initial conditions, and do these various realizations of 4 members with T126, and so there is corrected SST bias is corrected, and then another 4 members are done, and this is with T382, so again corrected bias, and then another 4 ensemble members, and a kind of multi-model ensemble is done for this ensemble prediction system, coupled global ensemble prediction system. So it's a fairly sophisticated system. So you can see that here it is GFS, which is uncoupled bias corrected. This is CFS, which is coupled. And this is GFS again with bias correction. So it is combining forcing of SST from the coupled model with bias correction in both cases with 2 different resolutions. So somehow they have developed this sophisticated system to do a multi-model ensemble, and we will see that this multi-model ensembling approach does improve the ensemble spread, reduce the RMS error, and extend the S2S forecast lead time, which is good. There is no unique way to do these things, how to generate ensemble ICs and so on, so they have done their own system. So comparison of IMD's declared and model forecasted monsoon onset over Kerala for 2001 to 2014. So these are hindcasts because the actual forecast, dynamic forecast, didn't start in 2001, started around 2013, I think. Nonetheless, every year IMD declares a monsoon onset several weeks before June 1st. So this year I think it's supposed to happen on May 31st. There was a cyclone Taukte, which tends to affect the monsoon trough, which is coming from the southeast from over northwest Pacific across maritime continent, South and South China Sea. And now another cyclone Yas is spinning up, which also can pull up the trough, monsoon trough, or like it did last year. And onset, which was predicted to happen on June 5th last year, happened on June 1st because of the cyclones pulling the trough along. Okay, the counterclockwise circulation. Okay, so looking at actual MOK, you can see it is around June 1st with plus minus 1 or 2, 3 weeks depending on whether it's very early or sometimes, let's say, this is none of them is very late here, but June, I think 2019 or 2020. 2019 was probably 3 weeks late, for example. Last year was on time. This year is supposed to be a day or two early. Forecasted monsoon onset over Kerala. And you can look at the standard deviation among the ensemble members to see if there is a relation between the delay or the difference between observed and forecasted, or declared and forecasted. So 2001, 23 and 25, 2-day difference, and ensemble standard deviation was also 2. 2002, 5, the difference was 8. 2003, standard deviation is 5 and the difference was 9. So essentially it is sometimes completely in agreement with the IMD declared onset, which is the observation. After the onset happens, IMD declares that the onset has happened, and then the forecast is compared against that. So got it right here, a couple of weeks early, one about a few days later. So essentially there doesn't seem to be a very systematic relation between the monsoon forecasted monsoon onset over Kerala and the actual onset and the standard deviation among the ensemble members. As I said before, there is no systematic relation between the onset and the seasonal total rainfall or the progression of the monsoon trough, or the number of active break periods, and so on and so forth. For example, onset can be late and June can be deficit rainfall, but July and August can be very heavy rainfall. So nowadays, even if the monsoon is normal by the definition of seasonally averaged all India rainfall, it still can have extreme large-scale rainfall events and local droughts that are pretty severe. So nonetheless, onset forecast is something of great interest, and there seems to be some skill, but it's not very robust, I would say. Okay. This is an example of the extended range prediction of monsoon onset over Kerala for selected years, shown here. The composite of rainfall in millimeter per day and 850 hectopascal winds during MOK day of 2001 to 14 in observations and MME is shown here in the right panel. So the colors are observations and the forecasts are shown here, and what can you say? Okay, here is the MOK ROK index and MOK index. So that is the monsoon onset over Kerala, and ROK has to be the rainfall. So you can see here 2003 and 2005, so accumulated rainfall. You can see the jump, the actual date and the predictions. So one is prediction, one is the declared date. So what can you get out of it? Well, as we said, there is some skill, but it's not as reliable as one would hope. But considering that the onset forecast is not extremely critical other than of great public interest, attempts will go on to make it better, but it's not clear there is a large-scale dynamic that drives the onset. The physics of the onset is discussed, and various hypotheses are made as to what determines the onset, and some people would say it has no meaning at all. It's like snow on Christmas. Doesn't mean anything about the actual winter season, for example. Okay.